gosh, because I have to run here, I'm sorry. All right. First question. Anybody have any questions about the homework or anything? Now, usually I get several every class. Yeah?
Any chance you could go over 2.56?
Sure, sure. By the way, all the problems I selected to give you, these are things that may give you a bit of a challenge, but all the information you have in class is more than sufficient to solve them in several ways, okay? So just remember this, it's not like these are over the top. These are problems that you should be able to solve with a little effort. Remember that. So this is 2.56. And here, looks like we have a current source of 2 milliamps. And then we have a resistor here. And we have a voltage source of 12 volts. A resistance, is that 1K?
Yeah.
Then 1K here. Oh, is that 2K or 1K? My book's got
1K up top.
And then is it 2K here coming down? Okay, that's fine. And they want this voltage, right? Now it doesn't say how to do this problem, but he shows you two currents that are mesh currents there. So probably most of you did this with mesh analysis. Mesh analysis. All right, that's the problem. And now we can do this two ways. We can use nodal or we can use mesh, either one. Actually, this problem is fairly straightforward, but we're going to go ahead and do it. We're going to use mesh analysis, which is the current analysis technique, okay? So right off the bat, before you even write this, what can you say about I1 just by inspection? What is its value?
2 milliamps.
You'll see it's 2 milliamps? That's simple, sure. I1 is just 2 milliamps. That's nice. So now, if I've got I1, I really don't have to go around this loop, do I? And by the way, this is something I didn't state. You can't sum voltages through a current source. You see how if you try to sum voltages here, it would make no sense because you don't know the voltage. Y'all follow me? It's the current that's given that. Now, that means if there's a current source in any kind of like a submesh or anything, you can't sum voltages around that closed loop. But if there's a current source, just by inspection, you know the value of that current in the submesh. Do y'all follow me, class? Give me a show of hands if you do. Okay? Good. So what am I going to do? I'm going to go around here. Am I not? Now, some of you, and rightly so, and I'm glad I'm hearing this from a lot of people, well, some people, they'd see these two resistors in series and they said, well, we know we can get V naught. I know that V out here is really going to be simply I2, whatever I2 is, times 2K ohms. Do you all see that? That is going to be V out. Do you all agree with that? So what I could do is just sum those two resistances and make them one. Now I know people do this, and I mean they're looking ahead, they're trying to reduce the number of calculus. Y'all follow me on that, class? If you want to, you can do that. You could just say this and this is just going to be 3K. You don't have to. And I'll even do something. I'm going to start right here, and I'm going to sum the voltages around that closed loop. Let's do it. So if I start here and I go through the 12 volts, is that an increase or decrease? Class?
Increase.
Increase of 12. Right? Now I'm going to go up through here. I always want drops, so I want to take the net current going into that. It's going to be minus 1K. What's the net current going in this direction, people? What's going up? I2. What's coming down? I1. So it's going to be I2, right? minus I1, because we want the voltage drop across here to be plus minus. Y'all follow me on this? Then it's going to be what? Now the voltage drop here would be what? Class? Value of the resistance is 1K, right? 1K. And what is the net current going through it? Just I2, right? And then minus, keep going, 2K times I2, right? All this equals 0, right? Y'all follow me? Simple. And by the way, this should be getting to be, when you're doing these things, by the end of this lecture and the next, this should be second nature. Because if you're struggling with this part, where we're going, it's going to be very difficult. This stuff, I know it takes a little time. Just do all the problems I assign, it'll become second nature to you. I mean, these are smart people in here. If we take a look at this, here's what I like doing. Well, it depends on how you want to do it. I'm going to take the 12 to the other side right away, okay? Whenever I say, y'all follow me, the 12 volts, it becomes minus 12, right? Now, it's up to you, but whenever I see a whole bunch of negatives, I multiply by a negative to get rid of them. You okay with that, everyone? So I multiply both sides by a -1. Gets rid of that, makes that positive, makes that positive, makes that positive. Good? Now this is me. You don't have to do it this way, but I don't like K's if I don't need them. So I'm going to divide everything by 1,000 ohms. Okay, class? You see those K's, K's, K's in there? Okay? When I get rid of it, divide everything by a K. This becomes 12 milliamps, right? Because I divided 12 volts by 12,000, by 1,000 ohms, so it's 12 milliamps. Y'all follow me? Give me a show of hands if you do. All right? Now, after this point, I organize things. I bring the I1 out front with its coefficient. In this case, I have simply I1, right? And it's just minus I1, correct? And then for I2, I have 1, 2, 3, 4, it looks like. Do you agree with that, class? You all see what I'm doing here? So it's plus 4, and this is going to be I2 equal 12 milliamps, right? Now this is the way I would do it if it was if we had two currents, two unknowns. But I already know I1, don't I? Isn't that right, class? I1 is what? It's right over here. I1 is 2 milliamps. So when I take I1 over here, it's going to be plus 2 milliamps. You agree with that? And finally, what can you see I2 is going to be? Well, here, that's 14 milliamps divided by 4 is equal to I2. That's 7 milliamps by 2, or 3.5 milliamps. That's I2. Do you agree with this? How many see this, class? You got it? All right. Now, that wasn't the question about this. What they want is V0. So how do we get V0? We take I2 and we multiply it by 2K, and we see it is 7 volts. Do you all see that, class? 7 volts. That's it. You agree with me? Who asked this question? You? That answer?
Yeah.
The real thing was just identifying I1 from just the loop. You follow me? Other questions about them? Yes, sir.
I still don't see how V naught is equal to I2 times 2K. Could you
Well,
explain that?
you see this is a resistance, right? And you know, if you have a resistance, the voltage across the resistance for a given R and a given current flowing in there, voltage is just equal to I times R, right? All right, do you know the I?
Yeah.
Do you know the R?
Okay. Yes.
It's got to be the voltage.
Maybe
Okay.
it's too complicated for
You with me on this, everyone? No dumb questions, believe me. There's subtleties that I don't know you don't know. Yes, sir.
Could you show how to set up the equation for 2.58?
I'd be happy to. And by the way, this is where it really pays dividends to do them all. I only assign a small portion. If I was sitting where you were, I'd do them all. When I did electrical, the problems get a little more complicated, but I did all the problems in the back of the book, and any problem that had answers especially, because that's the way you learn this stuff. I mean, you know, the MEs and stuff knows, and I'm sure all of you as engineers know, the way you learn material is apply formulas to problems. And professors come up with all sorts of bizarre problems that makes you really think about how to solve them. That's the way you learn this stuff. I'm just telling you the truth. This is 2.58, did you say?
Yes, sir.
All right. Now 5/8 one makes you think. For this one, they're all 1K, correct? Let's see. This is I1. This is I2. I want to tell you one other thing. Oftentimes people have this gut reaction of fear when they see things getting a little complicated and something they haven't seen before. Don't ever let that bother you. All right, all this stuff you can reason through. Doesn't matter how many meshes are up there. Don't ever let that bother you. Never be afraid of it. You have all the tools you need to reason through these things. When you do a problem like this is my suggestion. Don't just jump and start writing. Take a look. What do you know for sure? Anybody see something you know? Take a look. Yeah.
So is I2 4 milliamps?
Yeah, how many see that? In this sub-mesh right here, I2, without any thought, is simply 4 milliamps, right? Okay, good. There's a start. Now, keep looking at that. Get some good markers yet. If I'm looking at this, I don't go around this loop, right? Because that is a current source and I know I can't, yes sir? Or, yeah, ma'am.
Why is 4 milliamps not equal to I1 plus, or rather,
This is
I
what,
went
this is the
minus
current,
I2
this is,
or-
I2 is the current swirling here, right? This is
Okay.
I2 by itself, correct?
okay, but I see the 4 milliamps and then it splits.
No, you're talking about up here, it's gonna, some's gonna go this way, some that, we don't care about that. We're talking about in this sub-mesh, like right here, where there's nothing else circulating, it's gotta be I2. Do y'all follow me on that? Yes?
So the problem in the book has the other mesh current, instead of I3, it has it also as I2.
This is I2 as well?
Yes,
What is this?
both I2.
Well, then they made a mistake.
Okay, so it goes like, does that mean they're equivalent?
Two I2s don't work, all right?
Okay.
There's call that I2, call that I3. Maybe that was a problem. Whoever asked me about that. Y'all with me, class? There's gotta be something that designates one current different than the other. They can't have two simultaneous values that are different. All right, anyway, with this, you can't go around here because you would be summing voltages through a current source. That's disallowed. You all follow me? So, but we already got I2, so we don't need to do it. Check that box. Now, next thing is we got a loop here, and we got a loop here. So we have two places where we can sum currents, and we have two unknowns. We're gonna get two equations and two unknowns, right? How many tried this problem? Okay, if you did, you should have seen that this thing falls apart now. You do have to organize things in a matrix, but it should fall apart. All right, let's do it. Let's go around this loop first, all right? Now remember, I always take things as voltage drops, so I always want the net current into the positive terminal when I go around these loops, and I go clockwise. I'm gonna start here, and I'm gonna go around this loop where I3 is. If I start here, I'm gonna get a voltage drop, means I put a minus sign, 1K, right? Now what's the net current going up? Class?
I3.
I3, and it's minus I2, isn't it? Right? I3 minus I2. You all see that, class? I2 happens to be 4 milliamps. Agreed? Now over this way, what's the net current going this way? I want the voltage drop like that. Class? Well, I'll put the minus 1K. What's the net current? I3, right? Minus I1. Right? And then from here to here, what happens? Voltage drop, right? Do you all see it? Went from a plus to a minus. So it's minus 12 equals 0. Agreed? Now I could just drop it there. I'm going to go ahead and organize this one the way I usually do and try to get everything into a nice, neat form. So, and this is, I don't care how you do this really. I'm going to go through and first multiply by a minus 1, just like so, okay? Just doing it my way, all right? Now take the 12 to the other side first. I know it's going to be minus over here. And then I see I got something here. I got 4 milliamps times 1K. You all see how that's 4 volts? Milli is 1 over 1,000 times K is 1,000. It's really 4 minus 4. When I take it to the other side, it becomes what? Plus 4, doesn't it, class? Isn't that right? So then I get rid of that. I hope I'm not going too fast. I'm just trying to make the best use of the time. Now I'm down to this point, right? Just take a look. I know I've done a few things, but now what am I going to do? Probably. Well, how about this? How about I take care of this math right here, right? So I got minus 12 plus 4. Isn't that minus? Yes, miss.
Why is it minus 12?
Well, remember it was plus 12, right?
Okay.
And it went to the other side, it becomes minus 12, does it?
I thought it was
That was
minus
minus 12.
Yeah, but then we multiplied the whole thing through by a minus, didn't we? Am I doing too many? How many understand that, what I did? Okay, thank you. I don't mean to be doing too many things at once. I'm trying to get this thing down to a place where we can knock it out. So I think we're down to there, all right? You all agree I can replace this with minus 8? You okay with that in the back? All right? Right? Now, this is me. I don't like thousands, so I divide everything by a K, okay? All right, so if we divide by 1,000 ohms, we get rid of that, and this becomes minus 8 milliamps, okay? And now I just simply organize it. And from here, I'm going to put the I1 first, so I have minus I1, and then plus 2I3 equals minus 8 milliamps. When you get the final form of your equation, box it, call it equation. Like in this case, it's the first one, so it's equation 1. Got me, class?
Wouldn't that be equation 2 because you already had I2?
It's got the unknowns. That's a defined value. All right. I'm just the unknown equations because we're going to put a matrix together is what I'm going to go for. All right. Now, what's the next equation I'm going to do? And I'll do this over here. I'm going to start. It doesn't matter where you start in these loops. Now I'm going to go around this loop. Okay. Everyone. So when I go around this loop, these are all going to be voltage drops. Start there. I have what? Minus 1K, right? What's the net current, class?
I1.
Just I1, right. Now it's going to be minus 1K. Now what's the net current? Now this thing changes polarity, doesn't it? What's the net current going that direction?
I1 minus I3.
Right, I1 minus I3. Finally, right here, class.
I1 minus.
Minus first 1K, right? you're ahead of me, right? Go ahead, say it. I1,
Minus 4 milliamps.
right, minus 4 milliamps, very good. All that equals 0, correct? Take a good look. You all see what I'm doing? In the back, guys? All right, if you see what I'm doing, then the next step is what? Really, and you know, everybody's a little different. I like making it as simple as possible before I stick it in my calculator, stick it in a matrix solver. First, I just see all these negative signs, it irritates me, so I multiply everything by a minus 1. That's just me. Make them all plus. Right? After that, this is totally up to you, how you do it. Now the next thing I'm going to do is multiply the K and the minus 4 milliamp there. Right? 1K, 4 milli gives me minus 4 volts. Do you agree? And I'll take that to the other side. So now I'm going to go ahead and I'm going to say that goes away. I have minus 4 becomes plus 4 volts, right? By the way, that was I1, right? Yeah. Correct? Y'all, let me see this right here. Make sure you understand. I understand that you understand. All right. Now, again, this is me. I don't like the case. I divide everything by 1,000, right? Get rid of them. So get rid of that, that, and make this 4 milliamps, right? Agreed? And then what am I going to do? Organize, correct, class? I don't care what the word you use, but I want to get things grouped. Coefficients I1, coefficients of I3, and then the constants. And what do I have here? Looks like I have 3I1, right? Minus I3 equal 4 milliamp, right? And that would be my equation number 2. Now you asked about this. Who asked about this? Is that sufficient, or you want me to solve? You want to solve it?
No, that's good, thank you.
I'm going to see it right here. Y'all got your calculators? Let's try to solve this as a class. You've got your calculators. Let's see if we can do it. I'm going to put it into a matrix. So here, remember, those are milliamps now. So I have minus 1 plus 2, right? I1, I3, right? Equal minus 8 milliamp, and that's what, 4 milliamp. Coefficients over there are 3 and minus 1. Okay, you got your calculators? Go. Tell me what you get. I mean, please try to do this. This is, you know, you think I'm kidding about this, you do it in class, you find out where you fumble the ball, where things go wrong, and you solve it. And you got people right here, probably have your own calculator, the same calculator as you, and I send them your way if you don't know what you're doing with your calculator. Especially when you get into complex numbers, it comes in handy. I usually have people go berserk with, they get real imaginary parts the first time they make it. Give you a second. When you're done, if you can, give me I1 and I2, or I3, pardon. While you're doing it, I'm gonna get a drink.
I1 is negative 4.8, and I3 is negative 6.4.
Minus 4.8, did you say?
I1 is negative 4.8.
Milliamp?
Yes.
And I3?
Is negative 6.4 milliamps.
Anybody else? I'm not saying it's right. Anybody else?
I got I1 0, and then I3 was 4 milliamps.
I1 is 0,
I got
and I2, or I3 is what? Say it again? Say it again?
And negative 4 milliamps.
Right here?
Yeah, that's what I got as well.
I got the same thing as well.
How many got that second answer? I'm gonna bet it's right. All right, this is one of those things I've noticed. I'm gonna check, I'm gonna show you how to check this. Let's see, if I1 is 0, let me just see here. If I1 is 0, right? There's no voltage drop here. You agree with that? I1 is 0. Now, if I look at I1 is 0, I want to show you something. If I1 is 0, and you've given me I3 as what value now? -4. It means actually the real I3 value would be, it would be 4 milliamps this way. Y'all see that? Y'all follow me? I mean, if it's -4 one way, then it's positive 4 milliamps the other way. Agreed, class? Now watch this. Remember, this thing's 0, I1, so we don't worry about it. Let's see if it works. Well, I've got 12 volts. Now I've got 4 milliamps and 4 milliamps, 8 milliamps going this way, don't I, class? Y'all see this? 4 milliamps this way, 4 milliamps this way, gives me 8 down the center, correct? Y'all see 8 milliamps times 1K would be 8 volts, agreed? Y'all with me? Now keep watching. I got 4 milliamps here going this way. It means the plus minus value of that would be 4 milliamps times 1K is 4 volts, correct? Now look how this works. If I go around any closed loop, I better get 0 volts. Start here, increase of 8, increase of 4, that's 12. Minus 12 is 0. I think the second answer is right. As a matter of fact, that is the right answer, okay? Now, I want to tell you, if you didn't get that, go through and work it out, because I bet you, just bet you there's a sign error. Usually, it's the little things that mean a lot. Sign errors in matrices cause colossal problems, all right? I'm just telling you that right now. And I don't know how you enter your matrices in your calculator. In the stuff I'm used to, you put in your A matrix first, your 2x2 or 3x3. Then you put in your B matrix, that's the knowns. And then you solve for the inverse of A times B to get I1 and I2. But in some calculators, there's different ways to do that, and I am not really versed on all calculators. Out of curiosity, what kind did you have?
TI-89 titanium, but I didn't use matrices. I used the solve function and put in 2 different equations.
Okay, it should work.
Oh yeah, I'm sure I messed up somewhere.
All right, any other questions? By the way, that's a good question. Good problem, by the way. Y'all see this?
Ah, didn't figure it out.
Say again? Did you have a question, anybody? Yeah.
This analysis is called Kirchhoff,
Well, call it mesh analysis or loop analysis. It's based on Kirchhoff's voltage law. Even though we're solving for currents, we're summing the voltages around a closed loop equal to 0. And Kirchhoff's current law is really nodal analysis, right? Where we end up with unknown voltages, right? These are 2 methods that are useful, very useful. And once you get good at them, you can check your answers. You do it one way, we could just as soon put a ground here, right? And we could put an unknown voltage here, and we could solve for 2 unknown voltages. Either way will do you, all right? But I want you to get familiar with both of them. Now, any other questions before I continue? Yes, sir.
Can you go over 2.63 as well?
Sure. Absolutely. I didn't say this, but just assume that somebody you're around has probably been exposed to COVID. I'm just telling you this. If you feel anything coming on, go get tested. Please get tested. This class is large enough so I don't have to repeat myself over and over. You know that there's likely somebody that's been exposed. Just be smart. I'm just trying to tell you this for your sake and everybody that you're around. And I don't have any magic answers. I wish I could say we'll do this all offline for a while, but that ain't gonna work either. I'm trying my best. This is 2.63, did you say? Okay. These are good problems. If you look at the problems in your book, they have little square boxes and they ask for all sorts of abstractions. I don't like that. I like real problems with real numbers. I guess it has to do with stuff I've done in my past. want to tell you one other thing. There's a whole bunch of techniques that you can use to solve this. In the problem statement, it says use superposition. You don't know superposition, so you don't use superposition. Use something you know. We can do this. Is this 2 milliamps, by the way? All right, what they really want is that current there. Now I'm going to show you. Don't worry about the superpositions. We could do this with nodal. We could do it with mesh. Doesn't matter which one. They'll get you the same answer. Do you follow me, class? Doesn't matter. So what I'm going to suggest is this. I'm going to do this with nodal. Then I'll do it with mesh. That way you'll see. So if we're doing nodal, we ground something, don't we? That's V equals 0. Correct, class? And then what we do is stick the unknown voltages up there. Correct, class? So when we do that, we see we have an unknown voltage here at that node, and we have an unknown voltage here at this node. Y'all see that? Right? Now, if we get those voltages, it's pretty easy to get that current. Just take V2 over 4K, correct, class? So now after that, we have to identify currents, unknown currents. And I'm going to go down this way, call that I1. I'm going to go over this way, call that I2. And really, those are the two currents we don't know. Well, we don't know I0 either. But if you look at that, that's already designated as I0. Correct, class? All right, let's keep going on this one. So, if I go to node 1 here, and I say whatever flows in, flows out, right? Well, what flows in? 2 milliamps. What flows out? I1 and I2. What I'm really going to do is write it this way. I1 plus I2 here equals 2 milliamps. What goes into comes out. In this case, what comes out, it goes into. You with me? That's the first one. What about here? All right. Well, what is going into this node 2 right here?
4 milliamps.
Right. 4 milliamps, you're right. Plus I2, right? And what's coming out? I0, right? So I've got my two equations. I'm not done. I just want to write those before I put in voltages, okay? Everybody with me? Now, if we agree on that, I'm going to take the first equation here, and now I put things in terms of the unknown voltages. So what is I1 in terms of the unknown voltages, class? Come on. V1 over 2K, isn't it? V1 over 2K, right? Why don't we subtract this? Because it's 0. Correct, class? It would be pointless. So we have that. What is I2? Take a careful look. What is I2, class?
V1 over 2K.
It's what? V1 minus V2, correct? Over 2K, correct? Isn't that right? Got to take the voltage on that side minus the voltage on this side divided by the value of the resistance. Correct, class?
Yes,
The
sir.
voltage difference. That's equal to 2 milliamps. Okay. Now somebody else tell me what to do next.
Multiply both sides by 2K.
Yeah, why don't we go ahead and just multiply by 2K? We can multiply by K and by 2, but we'll do it all in one operation. So this becomes 4 volts, doesn't it? Agreed? Now what am I going to do? I'm going to group, right? So finally I get 2V1, right? Minus V2 is equal to 4 volts. This is the way I do it. I box it and call that number 1. That's the first equation. All right. I want you to all see it. There's nothing magic here. We're just defining things in terms of currents first and then currents in terms of voltages. Correct? What next? What about with this guy? I'm just going to go ahead and put the 4 milliamps down here. I know that's going to take. What is I2? Take a look at I2. Class? V1 or minus V2, correct? Right, it's V1 minus, this is gonna be the greater, it's the voltage where the current is entering, right, minus the voltage where the current is leaving, so it's gonna be V1 minus V2 over, say, 2K. That equals what?
V2.
Equals I naught, what is I naught?
V2 over 4K.
Right. Y'all see that? How many do? If you don't, tell me we are having problems. I mean, did you have a problem with that or?
V1 minus V2.
Remember, when we're talking, look at the voltage difference, we want this voltage, right? That's the voltage potential difference. Be the voltage on this side with respect to ground minus the voltage on this side with respect to ground. It's always the voltage difference, right, across the resistor. And because both of those voltages are measured with respect to ground, the voltage difference was just the voltage on the positive side minus the voltage on the negative.
If I2 is going the other direction.
Then you would do V1 minus V2.
V2 minus V1.
Or I'm sorry, V2 minus V1. Yes, it would be a negative. That's right. Y'all see this? Now, what am I going to do here? And this is up to you, but
Multiply that to 4K.
yeah, we could multiply everything by 4K. And if I did that, this would be 16, wouldn't it, class? I'll write it down here. Right? And then since I'm multiplying by 4K, it would be plus 2 quantity V1 minus V2, right? Equal V2. I'm going one step here to make sure everybody sees what I did, right? That's everything by 4K on top, right? And then, if that's the case, what am I, next step? It's just organizing, isn't it? How about take the 16 to the other side? All right, so it's minus 16. And then here, I have 2V1, right? And then I've got minus 2V2. The V2 comes up minus 3V2. Correct, class? So it would be minus 3V2 equals minus 16. And that would be your second equation.
And that's minus 16 volts, right?
Yeah.
Okay, just making sure I'm keeping up.
Yeah. All right, then we put them in a matrix. So then you put down 2, minus 1, 2, minus 3. And it's going to be V1, V2, column vector, equals, and then these are going to be 4 and minus 16. That's your matrix, right? If I put it together, correct, class? It doesn't matter which one you put on top or bottom. Yes, sir.
Why was it minus 3V2 in your?
Well, if you look at this right here, here's the equation. It's kind of fun. I have 2 times V2 with a minus. This minus 2 V2, and then a V2 pulls over minus 3 V2. Correct? It's just organized. Yeah.
Question for like V2 divide the 4K.
No,
This
no.
whole
We're,
equation
no,
was-
here we multiply everything by 4,000. Right? K is 1,000, so we multiply both sides by 4,000. This becomes 16, right? Well, I erased it.
I got a question about how you got the I set up the equation for deriving.
This equation?
Yeah.
This equation comes from right here, doesn't it?
Oh,
Okay. Thank you. Thank you. This happens to me all summer long. Thank you very much. Okay. So what did you get for V1 and V2?
7 and
V1 is what?
7.
And what is V2?
10.
10? Oh, good. How many got that? Okay. If you didn't get it, please try to find out where your error is. And this is real important. You get good at your calculators, because come Friday, you're going to need it. And you're going to have to be proficient, and you're going to have to be accurate. Now, one last thing. We didn't finish this problem. What is I naught?
10 over 4.
What is it going to be?
10 over 4.
it's gonna be 10 volts over 4,000 ohms, which is 4K, right? So it's 10 volts, because it's V2, over 4,000 ohms, right? And what's that, 2.5 milliamps, isn't it? Right? Just make sure you don't forget that K business. Got me, class? All right. Other questions? This is a good time to do this. Any other questions? Now, I want to say one thing. In the book, if I give you a problem and they solve it using superposition or using Thevenin or something we haven't covered, don't worry about it. Solve it the way you know how. And on Friday's thing, I'll probably tell you use nodal and use mesh, so you won't be, wondering and angsting over that. But mesh or nodal will do it. We'll do mesh now, okay? All right, we just did nodal. Does everybody agree with that? All right, I'm gonna erase this then. All right. Yes, sir.
How much time will we have to take the quiz on Friday?
I put it for the last 15 minutes in class, and I'll have somebody help me distribute them. And on Friday, what I'll do is organize it so you'll be sitting at least with one empty seat between you and your neighbor. And I may get 2 different quizzes, because that way, I hate to say this, but no matter what you say, there's going to be somebody that tries to cheat. And unfortunately, I try to prevent it. If I catch them, then the trouble gets astronomically high. Because I don't generally try to bury a kid, but when that's, especially when they call you for a reference for a job interview, if you say this kid's a cheater, it sort of throws you out. Right? I'm just telling you, don't cheat. It's a horrendous thing to have against you. So anyway, back to this problem right here. Now I'm going to go ahead. This is the original problem, right? Now I'm going to assign unknown currents. And I don't need this ground, but you can leave it there, not that it's going to change things. So the first thing I'm going to do is put an I1 there, and I'll explain this. Y'all follow me? Don't worry about the I0 yet. Then I got I2 here, but you'll notice that I already have 4 milliamps there, don't I? So what I'm going to do, just to be, I'm going to call that I3 in that direction, because I've already got it, I'm going to leave it in that direction. Y'all follow me? I could put it the other way and make it a negative, but I'm going to do it this way. Now, hear me now, so this is the part that gets a little confusing. Right in the center here, I have a known current, right? That's known, but it's going up. So that current is going to be the net current going up here, where I have 2 milliamps. Net current going up is I2, isn't it? But look over here in this other submesh, it would be minus I1. Now, do you all see that right there? Take a good solve. With me on that, class? I've got right there, I've got I1 circulating here. Part of the current in the center loop here, or in this leg right here, is going to be I1 coming down. But I got a submesh current there, I2, and the two superimpose there. It's like eddy currents if you've had fluid flow or anything like this. Do y'all follow me? So the net current going up is 2 milliamps, and that's equal to I2 minus I1 as I've drawn it. Y'all with me? Now, when I take a look at this here, I don't care about I0 right now. I know I0 is going to be equal to I2 minus I2 plus I3, right? Y'all follow me on that? If I get them, if I have I2 and I3, I've got I0. What I'm going to do is go around and find an equation, and if you look at this right here, just watch. I can't go this way, because what?
Current source.
Current source. Can't some voltages throw current source? I can't go this way because there's a current source. You all see that?
Yes, sir.
So what way can I go around a closed loop?
Through all the resistors.
See that? Y'all see that right here? Take a look. Is there any current source if I go around here? Right? It's a closed loop. I started here and I ended here. Y'all see that? How many do, class? All right, that's the thing you gotta know. I mean, because I'll see people doing this and this and this and that you can't do. You don't know the voltage across the current source, just the current flowing from it. So if we go around this, take a look, take all voltage drops. It's gonna start right here, gonna go around. It's gonna be minus 2, just 2K, right, times I1. Then it's gonna be what? What's the current through here? It's just gonna be what? Minus 2K times I2, right? Only I2, see that? It's the top one. Minus times I2, right? And then it's gonna be, now here, what is it? Minus 4K times I2 plus I3, right? Or I2 plus 4 milliamps, right? Equals 0. Y'all see that, class? Right? It's a little odd. Here's what I like going around there. No, you gotta go around where there's no current sources. You get used to that, you won't have any problems. So I got one equation, and I got 2 unknowns. Now, I'm a little pressed on time, so bear with me. Y'all see what I've done there? Here's my second equation. Right there. 2 equations, 2 unknowns. Correct, class? Can you solve it? How many believe you can? You're right, you can. And when you solve this, because I am just about out of time, when you solve this, you'll find out that that I naught is this, and it will be the same that we got before. What was it, 2.5 milliamps, I think, right?
Yes, sir.
You check me on that, all right, class? If you want to stay after and do this, I know I got another class coming in. Oi. Yes.
I